Okay, now we're going to do some word problems using the law of cosines, the law of sines, and of course maybe the area of a triangle, maybe SOHCAHTOA. We're going to just do a whole bunch of different kind of word problems here. So if you understand all of your trig, word problems are pretty easy. The only thing you have to do is draw your own diagram. So the most important part about this video is, can you draw your own diagram? If you can, it's pretty simple to do. So a ship in a gulf, 16 miles from one lighthouse and 28 from another. So obviously you're going to need a ship here of some sort. So there you go. There's a ship. And we have some water, because you're in, water. And let's see, one of these guys is 28 and one of these guys is 16. Does it really matter? Nope. Whatever side you want. So what you're going to do then is you're going to need a couple of lighthouses here. So you can have a little bit of fun and draw some lighthouses. And then all you have to do is figure out how far the distance is between the two lighthouses. And to do that, you need your angle of 120 degrees by the ship. And then you will find out what the distance is between those. So this is just a law of cosines problem, because it told you so. So all you have to do is a squared is equal to 16 squared plus 28 squared minus 2 times 16 times 28. And of course the cosine of 120 degrees. Make sure your calculator is in the right mode, and you will get 38.575. And that's it. You're done. Law of sines problem. So you've got a hot air balloon, and simultaneously two observers at points A and B 2.32 miles apart. And you're going to assume that the balloon and the observers are in the same plane, yada, yada, yada. So what is the distance from observer A to the bottom of the balloon, and what is the height of the balloon? So to do that, there is a couple of different ways you can approach this problem, but the first thing that you might want to do is find the distance from observer A to the bottom of the balloon. So you've already got the diagram set up for you, so all you need to do is find this little b. So you just need to use your law of sines. So you have the sine of 37 degrees and 40 minutes over your little b, and that's equal to the sine of 114 degrees and 2 minutes over your 2.32. Remember, triangles will always have angles that add up to 180 degrees. So that's why this guy up here was 114 and 2 minutes to begin with. You didn't have to find it using any trig. And from there, all you have to do is cross multiply, solve for b, and you'll end up with b is equal to 1.552 miles. So now we have to find the height of the balloon. So this is where you're going to have to possibly redraw your own triangle, because you only need to find the height now. Now you don't need anything fancy with law of sines anymore. Now you can just go back to good old-fashioned SOHCAHTOA. So if you draw just the left side of that diagram, you still know that this is 28 degrees and 18 minutes. And you're trying to find the height, but now you know that the distance from observer A to the balloon is 1.552 miles, which we just found. So then it's just good old-fashioned old-school SOHCAHTOA stuff. So we're going to use sine here because we have the opposite in hypotenuse. So the sine of 28 degrees and 18 minutes is equal to x over 1.552, and use your calculator, and you're going to end up with the height of the balloon is 0.736 miles. All right, and that's it. That's an example of a law of sine problem. Area of a triangle type of problem. So John's going to make a triangular shaped pen for his dog, and with the fence with the dimensions of 14 feet, 16 feet, and 120 feet. All we need to know is what's the area of the dog pen. So again, you don't have to use anything fancy. We have two new area of triangle formulas we can use, and since we have three sides, this is where you need the semi-perimeter one. So the first thing you need to do is find half of the perimeter. So you've got your 14 plus 16 plus 20, and that means your semi-perimeter is going to be 25 feet. And now you're just going to use the big old formula where we're going to have 25 times 25 minus 14 times 25 minus 16 times 25 minus 20. Type it all in your calculator, and you're going to find out that the area is equal to 111.243 feet squared. All right, so that's that. So there are some more word problems for you to practice, and what I highly recommend is that you attempt these on your own first, and then I will reveal the answers for you to see if you are doing these all correctly. Now, some of these are a little bit more challenging because they might be multi-stepped, but I still want you to try this first on your own, okay? So go ahead, pause it, try number 1. So let's see. The first thing you had to do is draw your building, and you needed 2 triangles here because it did say that at one point the angle of elevation is 17 degrees, and at another spot it's 31 degrees, and that distance between the two is 50 meters. So the first thing you needed to do was find x, or this distance right here, because you didn't have enough information from here. So after you figure out what this distance is, or x as I've labeled it, you just have to use the law of sines, and you'll find that from here to here is 60.427 meters. All I did was the sine of 17 over x is equal to the sine of 14 degrees over 50. And now that you have this, it's just good old-fashioned SOHCAHTOA again. So you have 31 degrees for your angle. The opposite is your height, and then x we now know is that 60.427 meters. So we just use the sine of 31 is equal to h over that, and we find that the height of the building is 31.122 meters. Okay, so again, it was a little bit of multi-step, but you just have to apply law sines and SOHCAHTOA. No big deal. Number 2, go ahead and work on this pool problem. And pause the video and press play when you're ready. If you got 58 degrees in 12 minutes, you're good to go because this was just a one-step, straightforward question. All the dimensions are already plotted on the diagram for you. The only thing you had to do is find the angle of incidence. So this was a law of cosines problem. All you had to do is set it up, and your 8.6 feet is the one that stands alone because we are looking for angle what I called A. And you use your calculator and you're good to go. So angle A should be 58 degrees and 12 minutes using the law of cosines. One more problem to go. So we're going to find the area of a field, and we're going to measure the largest angle in the field when given 3 distances. So again, this is going to be a Heron's formula for the area, and you're going to have to use law of cosines to find the angle because this is a side, side, side. So why don't you go right ahead, pause the video, give this one more try, and then we're good to go. And there you have it. The area, again, you just had to use Heron's formula. So find the semi-perimeter, which is 255, and then you just plug it into the formula, type it in your calculator, and you get 9,719.954 square yards. In part B, the only thing you have to remember is that the largest angle is always opposite of the longest side of the triangle. So once you draw your triangle, the angle you needed to find is opposite of the 225. So after you set that up, it's just law of cosines. You get 103 degrees in 35 minutes, and you are good to go. All right, so that is application problems with law of sines, law of cosines, some good old-fashioned SOHCAHTOA, and some area. This is Longo, and I'm out. See you, bye.